This man is Csaba. My name is Ben. We have a presentation about data in depin and what little role our project might be playing in this phase sometime soon. So first, Csaba will tell us a little bit about data in depin. We'll sketch out the problem space for you a little. After that, I'll tell you about Codex. Codex, what it is, who it's for, how it works, sort of. And after that, we'll tell you a little bit about who we are and how you can engage with us further. So first, okay, knock it out of the park, Csaba.
Okay, so depin. Depin is about infrastructure, right? And traditionally, infrastructure in depin is dealing about is centralized, it's incumbent, it's with monopolies, it's something with high entry barriers. Now in depin, we are doing incentivized decentralization to move away from this. These are resource networks, which are categorized as physical or digital. But when we are speaking of storage, like we are speaking of Codex, what is physical and what is digital is a blurry barrier. In storage, in data storage, providing, so on the supply side of storage, we need to provide infrastructure. Storage is heavy infrastructure. And the main challenge there is to not have a high entry barrier. And we might speak about how heterogeneous this storage is, or what is supported. More interesting is the demand side of storage. So a storage infrastructure can have different use cases. And I would like to focus on two aspects of storage on the demand side. One is being depin itself. So how many of you are building the depin network? I think most of you are building a depin network, right? How many of you building a depin network does not have to do with data? I think none of you does not have to do. Everyone has to deal with data when they are building a depin network. Every depin network is, except a few exceptions maybe, but it is very little, but usually data is underneath these depin networks. So you need, to run your own depin network, you need a storage solution. Would you run your own storage solution, or would you use a decentralized storage network as an underlying service under your depin solution? Another use case for a decentralized storage network is data which is related to the blockchain use space. And I want to dig a little bit into this one. And it's actually not just blockchain space, but it's the outlook of scaling of blocks. So if I find it quick, yeah. So we know blockchains are being modularized. Blockchains are traditionally about replication, and the application itself is not bad. We do replication, I mean, we don't do in Codex, but in general, replication is done in storage, and it's not evil in itself. What is evil from the performance perspective is replication to everyone. So replication to everyone is the worst scalability that you can have. It means everyone should have everything, and that means huge resource utilization. So when you are thinking of storage, physical resources are typically what comes to my mind is the hard disk, is the disk, is the storage, but it's also networking resources. And the application to everyone is just the worst for both of these resources. So we know what happens in the blockchain space. There is modularization. But it's important to understand that modularization does not solve the data problem. It just makes it more tractable. So traditionally in the blockchain space, you have kind of everything, everywhere, and for eternity kind of mentality, and that's what is changing. You need every data, everything, and that's changing because of layering. We are introducing layer 2s. That changes because the separation of execution and data sharding, and that changes because of data availability. You need data everywhere, and that's changing because of data sharding, and you need data for eternity, and that's changing because you are making execution history expiration, and because you are in data availability, you are only needing ephemeral data. So that's where the use cases came in. There are two main things, just speaking of the Ethereum terminology. There is the EIP44, which is execution history, basically cleaning, so the limited bounded time span of execution history. And this is some data. It's growing data. It's not that much data, actually. But if you are thinking of other chains, if you are thinking of the depin applications, if you are thinking of data generated by sensor network, for example, there is lots of transaction data potentially there. Another case of storage is the coming from data sharding, coming from EIP 4844 and dunk sharding. And there are lots of data. These are the data availability layers. And in Codex, we are going after these use cases. Codex, so you can solve these in centralized ways. You can try to solve these in altruistic ways. We are providing incentivized storage, and we think it's a prominent application for these.
Csaba? We'll take this thing. All right. I'll do the rest in 8 minutes. No problem. So what is Codex, our little project? It's a data durability engine and a decentralized storage network. So we focus, we have a lot of features that we want to build into the protocol and the application, but our focus is on censorship resistance and privacy. Durability being a close, third. So it has a bunch of aspects. We focus on durable data, we want privacy, we want dynamic data, we want censorship resistance, and there's a whole bunch of aspects that are in various stages of completeness that all connect together to make this possible. There's mutable data erasure coding, there's zero knowledge proving, but at the center there is a marketplace where the incentives play out in a marketplace between storage providers and people who want to purchase storage. Go a little faster here. Codex at this moment has 3 years development to it already under the IFT. We have a proof of concept. We have a working application. It's kind of buggy, but it sort of works. It's kind of nice. We have a marketplace that's running in Solidity. And the white paper is, of course, coming soon, TM, as they always do. So Codex is for, in general, 2 groups of people. We want to support both the individual users. Think of home stakers. We want you to be able to run this thing on your commercial hardware. But we also want to support people who just happen to have a data center and want to throw a whole cluster at the network. We want to be there for those people too. So that's from the storage provider point of view. From the user point of view, so what can you do with this storage layer? Well, pretty much we want to be as modular as possible. We want to support both user-facing and infrastructural applications. So you could think of your sort of decentralized Dropboxes or YouTubes or whatever. So think of dApps, basically. But you could also think of it as an infrastructure, part of your infrastructure, where you could put your blockchain archival data or put your blobs from your transactions or whatever. We want to support those cases as well. So how it works currently, this is all currently how it sort of works. It is a long story, but I'm going to try and do it for you in 5 minutes. So here's a little run through of the happy weather flow of the marketplace currently. So I drew a bunch, I was hoping I could point out the slides at this point, but they're all up there. So there are a bunch of spheres, and these are the nodes. The hosts, we'll call them hosts, these are the teal ones. They have data that they want to sell, or they have storage space that they want to sell to the network. And then we have the yellow ones, the clients, that have storage, they have data that they want to store in the network. So there's some data right there. And the flow goes something like this. First, we generate some parity data. How that works, very, very briefly, is if you have any 3 of these 6 blocks, you can always reconstruct the original data. So it's redundancy, right? So at that moment, the client who wants to store the data posts a contract for storage on-chain. There's a blockchain there where you're going to do all your payments and post your contracts and whatnot. So you post your contract on-chain, and at that moment, hosts who are pre-configured to want to sell storage space, they notice that contract on-chain, and they check if it fits with their storage capacity. So if it fits with the space, if it fits with the time that they have available, And then in this case, they decide that, yes, this contract fits for me. So they try and download some of that data. And then, once they have the data, they generate a proof of storage, and they post it on-chain along with collateral. The moment they do that, the moment they post their first proof and post their collateral, they're on the hook for that contract, for storing that data for the remaining of the duration of the contract. So, if they fail to store that data, then their collateral can be slashed, and if they fail to store that data long enough, they'll be kicked out of the contract and other hosts can pick up the slack using the parity data that was earlier generated to recover the data that might now be lost. So that means that periodically the hosts will be required to submit proof of storage to the chain so that they don't lose any collateral, and so that you as a client, as a person who purchases the storage data, you have some confidence that your data is secure in the network. Sometime later, the client can, of course, download the data from the host and access it in its original form. And sometime even later, the contract for the storage will run out, it will be finished, and at this moment, the host will be able to retrieve their collateral and retrieve the payment for their storage. Now, this is where you can find us. If you want to engage with us further, you go to codex.storage. We've got Discords, we've got blogs, we've got GitHubs and Twitters. You can find everything there is to find about us at codex.storage, including, the workshop that I mentioned earlier. You want to do it by yourself some other time, that's totally fine. You can reach out, we'll be available for help. You can find us, anything you can find about us, you can find at codex.storage. And with this, I'd like to thank you for your kind attention. And if you have questions or comments, feel free to seek us out.